Hey class, let's talk about section 8.1. Hopefully you have looked at my notes and we are going to go over them, see what questions you have if you want to print them off or just copy them down before you watch this video. That would be great. So let me pull up my notes. I'm going to hide this. I'm going to pull this up, make it big. Okay, so 8.1 is about hypothesis testing. So we are going to test a hypothesis. So a hypothesis, just like in science, is some kind of claim about something that we want to test. So the hypothesis test is a procedure for testing a claim. So we'll need to write down what that hypothesis is. So when we talk about property of a population, we're talking about, let's say, mean, the population proportion, standard deviation, whatever that parameter is, we are going to test it. So our first example, which we're going to use throughout this lesson right here, is 1,009 consumers were asked if they are comfortable with having drones deliver purchases, and 54% responded no. So our proportion, or our probability, is 0.54 in our sample. So our claim is the majority of consumers are not comfortable with drone delivery. So in order for us to say majority means more than 50%. That's what majority means, right? There we go. So we have to test that and see if that is really the case. So let's write out what majority means. That means that P is greater than 0.5. So among the 1,009 customers, how many do we need to get a significantly high number who are not comfortable with drone delivery? Okay, so this is relating to example 1. Claim is that P is greater than 0.5. So let's look at the results. Different results. So if we just talk about greater than 50%, let's say 50.1. And so that's what that is that's not significantly high. It's right there at 50%. So it's not significantly high. However, if we do 1,006, 1,006 out of the 1,009, that's 0.997, which that is significantly high. So now we need to determine, is 545 significantly high? So I'm going to show you how to do that. First thing we're going to look at is how to look at this on the calculator. Okay, so what we want to do is we are going to use one prop z-test, and that is going to help us to determine if it's significantly high or not. So we're first going to look at how to get it on the calculator, and then we are going to learn about what that means. What does that screen on our calculator tell us about, is it significantly high or not? So we go to stat, test, one prop z-test. Okay, so stat, test, one prop z-test. And then P naught, that's what that subscript of 0 mean. That's your hypothesized proportion. So in this case, it's going to be, so I'm going to write right here, example with drones. Our hypothesis is 0.5. That's what we're hypothesizing. So 0.5. X is your sample that said that they, of yeses, I guess, or no's, whatever we're talking about. So in this case, it was 545. And then N is our total number, 1,009. Okay, and then we're looking at that it being greater than. So we are going to use the greater than P naught because we want it to be greater than. Then we're going to hit calculate. Okay, and that gives us some information here. So we are going to write down the information that we get. So first thing we want to do is Z equals 2.55 because we're going to round that. And then P equals 0. Hold on, let me check something real quick. Let me make sure I did the right. Did I do the right? No, I should go over here and push enter. I don't know if I did that or not. Okay, there we go. Sorry, I made a mistake. Do something along the right. 0, 0, 5 is our, well, it's 5, 4. Let's do a couple significant digits. Okay. And then P hat, 0.54. That is what we have. That's what we have. Okay. So now that we have this data, we need to learn how to make a conclusion from it, understand what it means. And then just looking at technology, just looking at what it is not going to get us anywhere. We've got to know how to interpret it and make a conclusion. All right, so H, we're going to make hypothesis. We're going to write hypothesis. So HO is called H naught. That is your null. It's a statement about the population parameter is equal to. So on that last one, we'd say it equals 50%. This is true until proven otherwise. And then HA is your alternative hypothesis. It is what you actually want to show. So for the drone example, we might be writing this later, but H naught is saying that P equals 0.5. And then your alt is actually what you want to find, that it's greater than 50%. Okay? So that's how you write those two. We're going to do more of those. Okay, so here's your procedure for your hypothesis test. You're going to identify the claim, give it in symbolic form. So like we did earlier where P was greater than 50. Write your hypothesis. The easier one to write is your alternative because that's your actual claim. Your null, that's your parameter with the equal sign. It's always with the equal sign. The claim can be greater than, less than, or not equal to. You can use those symbols. And then you're going to select the significant levels. Usually 0.5 or 0.01 are your common ones. And then identify a test statistic. We have only covered normal and t. We're not doing chi-squared. And you're either going to look at the p-value method or you're going to look at the critical value method where you look at the actual data graphed. So with p-value, you're going to find the value of the test statistic, which over here, this is your test statistic. And this is your p-value. So you're going to look at those. Okay. And then find the value of the t. We already did that. Reject HO or your H naught if the p-value is less than your 0.05 or 0.01. Fail to reject. We don't say accept. We say fail to reject the null hypothesis if the p-value is greater than whatever your significance level is. And then you're going to restate in non-technical terms. When we're doing the critical value, I'm going to explain these more in detail in a little bit. Find the value of the test statistic in critical values. Reject H0 if the test statistic is in the critical region. So here we are going to actually draw your normal curve, and then we know that this is z equals 0, and then we'll go up or back depending on where it's at, and we're going to see if it's in the critical region, and I'll show you that too. If you're going to reject H0 or the null hypothesis, reject null if the test statistic is in the critical. Fail to reject the null if test statistic is not in the critical region. So you're going to determine what that critical region is. And then, of course, restate. Okay, so step 4 is talking about the significance level. So we're going to look back at that. That's the probability of mistakenly rejecting the null when it is true. So if we refer back to 7.1, we can look at what the significance levels are, and that will be given. Step 5 is identify the statistic relevant to the test and determine its sampling distribution. So this kind of refers back to chapter 7 as well. So we will not cover any chi-squared. So these are the test statistics that we'll use, okay? So this is with your parameter of P, your parameter of your mean. So anytime you're asking for a parameter of P, this is the test statistic that you'll use. If you're asking for the mean parameter and it's not, the standard deviation is not known, that's when you'll use the t-test. If your standard deviation is known and you're finding the mean, and you got to look at these other 2 requirements, you'll use the z-score, z-test, normal z. Okay, so let's look at the next page if I can get it to open. There we go. All right, go back to example 1 with your drone delivery. We are going to write as much as we can on this, and we're going to refer back to this back and forth as we talk about it. So step 1 was your claim. Majority of people are not comfortable with drone delivery. So step 2 is you're going to write it in terms of symbolically. So P is greater than 0.5. Majority means more than 50%. And then here's all of our data that we know. We know that there are 1,009 samples, 545 that are not comfortable with it. Our P we're looking at is 50%. Oh, the probability of there's a yes and a no. So probability of a no is 50. Probability of a yes is 50. This is called you're not comfortable. You're either not comfortable or you are comfortable with drone delivery. Those are the only 2 outcomes. And then P is how many we got that were not comfortable. That was the 545 out of the 1,009, which they gave it to us was 54%. Write your null and alternative. So H naught and H alt. So your null is going to be that P equals the 50%. And this is your claim. I should have wrote that one first. P is greater than 50%. Okay, significance level. We are going to use a significance level of 0.05. And this one, it didn't give it to us, so we are going to use the most common, which is 0.05. Step 5. What is step 5? Oh, identify the test statistic. Okay, we're doing proportion, so we're going to use our normal z. So we need to check those requirements. So the requirements are NP and NQ. Well, we know that's going to be more than 5 because if we do 1,009 times 0.5, 504, and then do 1,009 times 0.5 again, right, is 504.5. Okay, so those requirements are met. So now do your test statistic. So I'm going to write it over here. Is z equals p hat minus p over square root of pq over n. So our p hat, that is this. This is p hat. I should put p hat there. Sorry. So that would be 0.54 minus p 0.5 over square root pq. So that was what we said. Oh, no. It'd be 0.5 times 0.5 over square root. Oh, not square root. I already put square root. Sorry. 1,009. So that's what we'll put. So it's a fraction. So we do 0.54 times 0.5. Oh, not times, minus. And then square root, and then another fraction. It is 0.5 times 0.5 over 1,009. Okay, so that came out to, we can write it here, 2.54. Okay. Now our p-value. So we're going to use our p-value or our critical value method. So we haven't actually covered this in detail yet, so we're going to come back to it. So let's look at step 6, the critical value method, which it says your p-value, test statistics. So critical region is a rejection region. So if it falls in this area, then you're rejecting the null. So when we say rejection, we are rejecting the null. That's the only one we can reject. We can't reject alternative. We can reject the null. So the area corresponding to all values of the test statistics that cause us to reject the null. So the only way you use a two-tailed is if your alternative is the not equal. You're going to use a left tail if we have the less than symbol, and then right tail if we have greater than. And in this case, we have greater than. So we are going to look at that greater than 0.5. Okay, so we need to find that critical. So whenever we do this, this will be at z equals 2.54. So we need to know what that critical value is for this. So let's see. So then we know that our significance is 0.05. Oh, this is for critical value. I had these switched. So it's going to be, we need to look at the area. So whenever we do we're doing alpha is 0.05. So then that's what this critical area, well, something like this. So what is this value? Is it over here? Is it here? And what we have is that your critical value, whenever we do, we want 90%, right? Yeah. Because you're going to have 5 on one side, 5 on the other. So that's 1.645. So this is 1.645. Because you want 5% here. And so that means 5% has to be here. So in here is your 90%. So then that's your critical value. So because this is on this side, it's in that area. So if it's in that area, that's your critical area. That's your rejection area. So this is for critical value. So 2.54 falls in rejection area because it's inside that area. Okay, then the next one is your p-value. Probability of getting a value of test statistic that is at least as extreme as a test statistic from the sample data, assuming that the null hypothesis is true. Don't confuse p-value with parameter p. So there's the different types of p-values. So remember that p-value that we got earlier at the very beginning from our calculator? Where was it? There's this one. P equals 0.005. So our p-value is 0.005. Okay, so is this less than this, our test statistic? This one is less than that, and that's what we want because that's what it said. Let's see, trying to go back and forth. Here it is. I hadn't actually got to this one. Make a decision to either reject the null or fail to reject the null. If p-value is less than alpha, reject null. So that's what happened here. P-value less than null, reject. P-value greater than null, fail to reject. So what we have, our p-value is 0.005 and 0.05. This is less than that. So that means we are going to reject the null. That actually should go here, step 7. So let's see. So then we have same thing over here. It falls in that area. So that means we are going to reject. So here we are going to write reject null. Because p-value is less than 0.05. Okay, so then step 8 is our last step. So let's go to where we're talking about. Step 8. Restate the decision using simple and non-technical terms. State a final conclusion that addresses the original claim with simple wording. So we are rejecting the null. Original claim does not include equality, so that's part of our case. You reject the null, and you reject the null. We did not fail to reject. It did not include equality. So then this is what we are going to write. And this one's fail to reject. So both of these are fail to reject. And these are rejecting the null. So the only ones I want to look at are these two. So does the original claim include equality or not? Original claim is saying that it's greater than 50%. It's majority. So it does not include equality. So we are going to write there is sufficient evidence to support that the claim, that, so that's what we're going to write. There is sufficient evidence to support the claim that the majority. Marcus, will you shut my door? Of consumers are not comfortable. Shut the door. He's at a meeting over there. Majority of customers are not, because the claim was majority of customers are not comfortable with delivery. So we're going to say that support the claim that the majority of customers are not comfortable with drone deliveries. Okay. So we have tested the claim. We have determined that there was sufficient evidence to support that claim that the majority of people do not want drone deliveries. All right. So we have done through page 7. Let's see. All right. So more on restating our claim. So say fail to reject the null hypothesis instead of accept the null. There's two different things. We don't have enough evidence to say we accept it. We just fail to reject it. Accepting is misleading because it implies that the null hypothesis has been proven, but you can never prove the null. The phrase fail to reject says more correctly that the available evidence isn't strong enough to warrant rejection of the null. Final conclusions can include as many as 3 negative terms, but it's confusing. So there's not sufficient evidence to warrant rejection of the claim of no difference between 0.5 and population proportion. That's confusing. Until stronger evidence is obtained, continue to assume that the population proportion is equal to 0.5. So that would be a better way to write it. Okay. Then we have 2 examples we're going to do, and that is it for these notes. So let's look at this claim. The mean pulse rate in beats per minute of adult males is equal to 69 beats per minute for a random sample of 181 males. The mean pulse rate is, for a random sample of 181 males, the mean pulse rate is 70.6 beats per minute. Standard deviation is 12.3 beats per minute. Find the value of the test statistic. Okay, so we need to look back at page 4 of these notes. So we need to find our test statistic. So that's like your Z or your T. So what do we have right now? We have the random sample of 181. So we have that N equals 181. Then we have mean pulse rate is 70.6 with a standard deviation of 12.3. All right, so let's look at page 4 to figure out what test statistic we need to use. Page 4. All right, so we are looking at the mean, right? Mean of 69. That is our claim. So we're looking at these two, between these two. And we do have standard deviation, so it's going to be this one. We are going to use normal Z, and Z is going to equal X bar minus mu over standard deviation over square root of N. Sorry, you couldn't see that. So that is how you're going to find your test statistic. So let's look. X bar is 70.6 minus mu. That is your mean that we're looking at. So this is mu, 69, over standard deviation 12.3 over square root of 181. So that's how we're going to find our test statistic. So let's see how we are going to do this. So we need a fraction. 70.6 minus 69 over another fraction. 12.3 over square root 181. And that is 1.75. Okay, so that is your test statistic. There we go. Okay, number 2. The test statistic of Z for something else is 1.24 is obtained when testing the claim that P is greater than 0.6. Identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. So if we have P is greater than 0.6. So remember how I talked about left-tail, right-tail, two-tailed? It was on page 6. Okay, this says P is greater than 0.6. So the greater than is the right tail. Because P being greater than 60. Find the p-value, 1 minus alpha. So our p-value, so we're talking about our 1.24 is your test statistic, and we want the p-value. So we need to do, we need to find out what 1.24 identifies with as far as the area. So this is what we have to go to the positive z-scores. Okay, so 1.24. So 1.24 is right here. This is your positive z-scores. 1.24, 0.8925. The area here, is 0.8925. So in order to find the area here, we have to do 1 minus 0.8925. So 1 minus 0.8925 is 0.1075. So that is going to be, but then, yeah, that's it. So 0.1075. And then identify the decision criterion to make a decision. Are we going to reject or fail to reject? So the p-value, so this, if we are using our critical value, don't we want to use alpha to be 0.05? 0.05. So when we look at this, and we look at this, because this is your p-value, this is greater than that one. So in that case, we are going to fail to reject. Okay, so make the decision. That means we're going to fail to reject that claim. So whenever we fail to reject, then we're saying there's not enough evidence to prove that P is greater than 0.6. Okay. All right, so that is it for these notes. If y'all have any questions, please reach out to me, send me emails. We can meet on Google Hangout. I can help you out however you need. All right. And y'all have a great day.